today I'm going to explain a project about a chatbot, which is a college inquiry chatbot. Which I made personally for my college. And yeah, it goes like this: the data for the project is taken from Kaggle. It contains many intents, which is wrapped under this list intents. Yeah, the intents contain text and the response and extension content. Text contains the data which the user will give, and and the response will contain. The response will contain the bot will reply to the particular input present in this text, and the extension contain, if you want, other than this, if you want to add any functions, entities or responses, that will be present in this extension part. And this context part contains the if you want to maintain any previous context about the conversation, this context part will be used in this set to blank, and the name of the context is referred as greeting, user request, and the clear is set to false. Nothing but this says that we have to maintain the content of the previous conversation. Yeah, this is nothing but this is set to false. So the previous content should be maintained. Yeah, this was we have many entities, like here we have greeting, and here we have goodbye, and we have creator, like this, so on. We have n number of intents here, like scholarship intent, discuss about scholarship, and like facilities in the college, etc., and uniform. These are all the intents. Based on these intents, particular output will be generated from the bot. This was about the data set. And now coming to the dataset which is present, should be some majority cases will be uploaded to the databases, because the dataset may be large. The space required in a local system not be as much as required for the dataset. So we use MongoDB to store the data. Yeah, in this project I use my local system so that my dataset is very small. So I use my local system, and for MongoDB compass we are connecting here, and the database name is ChatbotDB, and the connection name is intents. And this part, yeah, here we'll upload the data, and we have a ChatbotDB and the connection, and this is the name of the collection. This is the name of the database. From this JSON file, we are uploading those JSON file into this MongoDB, and we are performing insert one. The data will be inserted to the MongoDB. Yeah. And finally we'll use the data, and in MongoDB fetch we'll fetch the data and store it intent data, which can be used for the further usage. I'll mention where it will be used. After the data is obtained, before sending into the model, the pre-processing of the data should be done, and this will be done in the pre-processing module. Yeah, my project is divided into several modules, because for easier understanding, all these things can be done in a single code. To maintain the modularity, each part is broken down into simpler parts, so that it provides modularity. Yeah, that was about modularity. And then the cleaning part. Yeah, the data cleaning. We have the data cleaning part here, and we are importing many libraries like NLTK, NumPy, and lemmatizers, etc. These are the natural. These all are the natural language processing (NLP) techniques used to clean the data, so that our model will understand it easily. Yeah, this returns the parent folder present in the parent directory. From the database folder MongoDB fetch, the intent data can be used. We are downloading the required modules, and we are using it. Lemmatizer we are initializing it. Let me explain what is lemmatizer. Yeah, lemmatizing is nothing but bringing the word into its root word. Like, I think we have the word like running, ran, etc., like eating, eat, ate, etc. These all word will be scaled down into its root word. Root word is nothing but example for running, ran. The root word is run. Like, all these words will be scaled down to run or eat, so that our model understands it is rooted form, to reduce complexity. This was about the lemmatizing. And the stop words. Stop words are nothing but the words present in English. Not only in English, we have many number of stop words present in Germany, Spanish, etc. These stop words are the word like is, the, and all, which does not contribute much in providing the meaning to a sentence. Yeah, this was about the stop words. Yeah, the removing the stop words in a sentence will not affect the meaning also. So we will remove the stop word present in any sentence. This was about the stop words, and yeah, let's dive into the main concept here. Pre-processed text. What we will do in pre-processed text is nothing but we are creating the words to store the unique words, nothing but the vocabulary. We are maintaining the vocabulary in this list called words, and the classes contains the name of the entities, as I mentioned. Like, yeah, this is the name of the entities. Like, we have, sorry, yeah, these are the name of entities like admission, greeting. Yeah, those are the entities. Yeah, these are the entities we will get same. These entities will be storing in this part. Will be storing in classes, and the documents contains both the list of words and the entity labels. the document contains both the thing. What we are doing in that, in data, we will pass entity data which is coming from the process data. From fetch data we are fetching the data, right? That data, from that data we'll pass here, no? In that data we will find the intents. From that intents we'll take the particular intent. In that intent we'll look for the text. In that, for that pattern, you will see here, we'll apply the word tokenizing. Word tokenizing nothing but we will break the sentence into a simpler word. This was about the word token. Nothing but, think, if you have the word he is running, the sentence is broken into he is running. These are the comma separated values stored in a array. Yeah, this was about the word tokenizing. And what we are doing here, we are applying lemmatizing, nothing but, yeah, the word will remove by is all, will remove any special characters, and we'll apply lemmatizing, and we'll apply the lowercase when stored in a word list. And we'll find here we are removing the stop words, and we are finally extending to word list to this word. As I mentioned, it contains unique vocabulary. Yeah, as unique means nothing but we are using set which removes the duplicate. Yeah, that was the vocab words. And the document we are applying the word list as well as intent. This is nothing but the label. It returns the label of a particular intent. If the intent is, the finally we are appending the classes contains, as I said, intents. If it is not present earlier, we are finally appending to it, and the words will finally sort it, and will remove duplicates, and will finally return it. This was the data cleaning part. We'll perform some EDA and feature engineering techniques to know more about our data. What we are doing is nothing but, as I said, our classes contains the label entities. We'll count the entities by using counter function. We'll count entities. What are the count entities contains nothing but, let me show you. 1 second. Yeah, this is the entities name with their counts like 1. This is the count of entities that which will be mapping here. Yeah, this is our data, as it says. 1 second. This is the data like backlog queries, college architecture, college alumni, college culture, etc. These are the entities present in our data set. After this we have this is the EDA part. Yeah. After the the data cleaning part, after the data cleaning part, the next step is to train the model. That we are doing this code. We are importing the required libraries, and we are initializing lemmatizer and empty training data array, and the training empty which is array, and the training which is blank, which is the output empty, which contains the array of zeros. And in documents we are iterating. As I mentioned, documents contains the list of words and its label entities, separated by commas, and it contains, what we're doing actually here is we are returning a bag of word vector for a particular word. We're applying them for words in word. We'll find the in document, as I said, the first comma separated values contains the word. From that we are taking the particular word 0. If the particular word which is coming from the data is present, then we'll apply as 1. If it is not present, we'll apply 0. But before that we'll apply lemmatizer, and we'll apply lemmatizer, and we'll convert it to lowercase, and this the array contains like array of 0 that will be stored in the output array. And as I said, the second part contains the output label. This will return one not encoding of the label part, intent label part, that will be stored in output row. And finally we are appending to training data. The training data contains the data required for a training, that may be extend and bytrain. And finally the extend, we are putting the bag of words, that is nothing but the number of words. And for bytrain we are putting the intent labels, that is the one not encoded value. This is the bag of words value. And finally we are training our model. We'll initialize the model with sequential. Here we have the input layer, we have the hidden layer, we have the output layer. And the first input layer has 128 neurons, and the size of the input should be the size of the training data. So we'll use the length of the extend, and we'll use the activation function called relu. We can use other activation functions also, like other variants of relu, which can be useful. And we are using our dropout value 0.5. I think, but we are dropping 50% of the neuron, like we are inactivating the 50% of the neuron, so that we can reduce the overfitting in our data. And we have the hidden layers of 64 neurons. Activation function is value, and again you are dropping 50% of the neurons. And the output layer should contain the size of the output data, so we'll use the length of the white train. And the activation function is softmax, because we are using multi-class classification. We are using softmax. Softmax is nothing but It's a function that returns the list of probabilities of a particular word. Like for a word, it may return the particular related vectors like 0.75, 0.99, 0.05. Out of these, the maximum probability will be chosen as output. Yeah, this was about softmax and the model that compiled. We are compiling our model here. We using categorical cross entropy and optimizer Adam and matrix accuracy. Optimizer Adam because it is the we are using optimizer as Adam because it combines both HDC momentum and RMS prop. HDC momentum stands for stochastic gradient descent momentum. Here, if any noise is present in data, which can be smoothed in this function, combined with RMS prop, we'll use optimizer as Adam. Finally, we are fitting our model with extend and wide range with 200 epochs, and the batch size will be 8, and our purpose will be one. Nothing but we will get a description about the data when we are training, and finally we are storing that. Finally, we're storing that into nothing but we're finally converting our model and storing into H5 file so that we can use it for the further details. Like future purpose we can use. This was about the training part. After the training part, we have the prediction part. In the prediction part, we have what we are doing is nothing but the same importing part here, and we'll check before continuing the prediction part. We'll check that the SO file is present or not. If it is not present, it will return. If it is present, we load that we load that path into the model, and here we'll apply the bag of words and predict. We'll predict the intent, and finally we'll get the response. Let me go deep into this. What we're doing here is if a user gives any input, that word will be as I mentioned before, the word tokenized. What it does, it will break the words into, it will break the sentence into words that will be stored in sentence words, and finally we are applying lemmatizing, and this will return the array of zeros and ones. It will return the type of the bag of words, and these bag of words will be stored in the BO that is the bag of words, that is the bag of words. And we are finally predicting the model, and it will be stored in the response form. This response contains it contains a probability of list like 0.07, like these values will be present. Out of that, we will choose the maximum value. Example, think it returns values like 0.09, 0.01, 0.075. Out of this, it will choose the value 0.09, and it will return an index 1. From that index, the classes, as I said, the classes contains the intent labels. From that intent label, the second, like the value returned once, right? The thing, but the intent from the classes, the second intent will be returned from the predict intent. This was about the predict intent, and then finally we'll predict the response. When you put the user response to this get response, predict intent, that will return an intent. From that intent, we are from this intent in intent data, we are finding the intents. Example, let me show you. Here we have the first data. We are on intent data. From this intent data, we are finding that particular intent. If it matches the particular intent, we'll choose the particular response randomly, as I mentioned before. If the example, think of situation where example, this is one intent. Let me show you. This is example. The user input. Let me give you a whole explanation about my project. This is think. What is my college placement? If a user gives any of this input, the intent will match with the placement. Right. That during that time, the response will be chosen randomly. Like listen. The response will be chosen randomly. Like see, hi, hey. Out of these, any of these response will be chosen randomly and given as output. This was about the output part. This was about the output part that is chosen chosen random and given. If it is not there, it will return. I am not sure about that answer. This was about the prediction part, and finally we have. After the prediction, we have the app.py. It is a Flask folder which we will run our HTML and other files, and this is the HTML and other part. And finally we have the this was the main working of my chatbot, and these part are related to the deployment and the front end part. With the front end part, we have the static file like script files and style files like CSS files and all, and the templates part we have in HTML files and all. This was my project, and the project took like this. Due to time constraint, I have already imported the data. Hello. Here, example, if a user input says hi, the user input says hi, the chatbot replies that hi, how I can help you. And hello, if a user says hello, it will reply good to see you again. Yeah, this was the like normal conversation. Like user gives the location, it replies with the location. Like we have two branches in north and south. If you click on this particular link, we will get the particular location of the college. And yeah, this was this is the main function of the model is that I think user gives a query that has college contact number. This the bot will reply the college contact number. If the user gives the contact number also to reply the college contact number. If you reply college number also to reply the college number. What the model does it understands the user content, user the query, the intent of the query. So it will reply the based on the user requirement, it will reply the contact number. This was about the chatbot, and yeah, for college timings, it will reply college timings for nearby places. For nearby places also. See here we have nearby places. It will reply some data like Mysore Palace, Chamundi Hill, and St. Philomena, etc. If a user put the input like places to visit nearby, for the both inputs, it will reply the same output like Mysore Palace, Chamundi Hill, and St. Philomena. The bot understands the intent of the user and replies for that. If a user gives the unwanted inputs like this, the model will reply, "I'm not made for this" and all. And if a user replies queries the thing that was not to be inputted, yeah, the user will warn him like, "Please use the appropriate language." If the user want to inquire about the syllabus and all, the user can inquire it, and like details of the college and the placements about the college. Yeah, here we have if you ask a bot about a particular question, see here we have who is the computer science HOD. The bot will reply the particular name, and the HOD of computer science, the bot will reply the particular name. The bot understands that both the question refers to the same intent to reply to the response present in the particular intent. Yeah, this was the major response of the model. Yeah, here we have exams. Yeah, and then in the canteen information, if you click here, it will go to the particular page, and it will show. Yeah, and it is a canteen, and details about the canteen. If a user put the text name not required, like "I am hungry," reply, "I'm not programmed for this, I'm hungry." Yeah, this was the whole working of my project. Yeah, yeah. The main chatbot is designed for the users, like new students who are getting to the college. They have to know about the college and its surroundings and environment, and all the details of the college will be present in a particular place, so that the students cannot roam here and there for the data. They get all data in a single platform, so they can browse the data without the fear of inquiring with seniors and hesitating and all. Yeah, this was I felt it was very required to implement this. Yeah, this was I designed it for my college. It can be customized according to the based on the college and the data. The data will be static here. Yeah, which can be improved time by as the time goes on. As the data increases, the model accuracy also increases. Yeah, this was the whole thing about about my project. Yeah, thank you.